Hi. Even though passing of examinations is very important, if you approach mathematics with the mere aim of passing the examinations and scoring high marks, the chances that math is going to be boring. If you are going to learn mathematics because of the periodic tests, mathematics is going to be extremely boring. Now, I will try to make it clear why you should give greater emphasis on mathematics and English. Mathematics, rightly viewed, possess not only truth but supreme beauty. Mathematics is capable of giving you happiness, which is comparable to the pleasure which you can derive from music. This is the viewpoint of the greatest mathematician and philosopher, Bertrand Russell, who got Nobel Prize for English literature. When Bertrand Russell was very young, he wanted to commit suicide. He was about to jump into the sea when a sudden thought occurred. If I die, how will I study mathematics? Immediately he ran back. He wrote several books. I used to read his books when I was young. I used to derive a lot of pleasure in reading his books. Scoring marks is important, but acquiring knowledge is far more important. Maths and English will help you to acquire knowledge in other subjects. So my advice is not to study maths with the mere aim of passing the examinations. Try to derive pleasure in acquiring knowledge. I hope and wish that all of you will try to do so. Matrix is an important branch of mathematics. Using matrix, we can solve system of linear equations. It has got a wide application in chemistry and physics. Today we will see adjoint of a matrix. When you take a square matrix, with each square matrix, we can associate a number known as determinant. For getting the determinant, we should know the minor of each element. For example, this square matrix generally can be represented like this. First element is 2. For that we can write A11. Second element is 1. For that we can write A12. Generally it can be represented as capital A is equal to Aij. Minor of this 2 is represented as M11. This 2 is occurring in the first row, first column. Delete that row and that column. So you will get a submatrix. Determinant of that submatrix is called the minor of this element. Similarly, we can get the minor of all the other elements. Minor of the second element, 1. Delete that row and that column. The remaining matrix, submatrix, determinant of that submatrix is the minor of the second element. Like that, you can get the determinant of all the submatrices. So that is the minor of each element. Then let us see the cofactor. Cofactor of the first element. The first element is 2. Cofactor of the first element is minus 1 raised to 1 plus 1 M11. So whenever this I plus j is an even number, cofactor and minor will be the same. Minor is minus 1, cofactor is also minus 1. Next, cofactor of this second element. Cofactor of the second element is negative of the minor. Minor is minus 1, cofactor is plus 1. So whenever I plus j is an even number, minor and cofactor will have the same sign. If it is I plus j is an odd number, cofactor will be the negative of the minor. So you find all the cofactors. Then if you write the matrix using these cofactors, that is called the cofactor matrix. You take the transpose of the cofactor matrix, that is what is called adjoint of the matrix A. This is a square matrix which can be represented like this. Adjoint of that matrix can be written like this. Cofactor of A11 is capital A11. Cofactor of the second element A12 is capital A12. So adjoint of a matrix is the transpose of the cofactor matrix. So the cofactors of the first row is written as the first column. So this is the adjoint of this matrix. Cofactor of the second row is written as the second column in the adjoint of A. Now let us multiply A and its adjoint A. A is this matrix, adjoint of A is this matrix. Then plus one, you might have studied how to multiply two matrices. Multiply each element of the first row with each element of the first column and add it. So you will get the determinant of A. We are multiplying each element by its own cofactor. A11, capital A11. A12, capital A12. A13, capital A13. That means you are multiplying each element by its cofactor and adding. So you will get the determinant of A. Second element will be 0 because you are multiplying the elements of the first row with the elements of the second column. So you will get 0. Similarly, you multiply all the column with the corresponding columns and you will get A into adjoint A like this. In this determinant A you can take outside. After that you will get an identity matrix with order 3. So from this we can get a very important one rule. A into adjoint A into adjoint of A is equal to determinant of A into I3, where I3 is an identity matrix of order 3. When you multiply each element by the cofactor of the element and add, you will get a determinant of A. That means whenever I is equal to j, you will get a determinant of A. I is not equal to j, you will get a 0. That is why here you are getting 0. For this, I is same as j. Here I is 1, j is also 1. Here I is 1, j is also 1. Here I is 1, j is also 1. So whenever I is equal to j, you will get a determinant of A. I is not equal to j, you will get 0. So this is an important result. A into adjoint A is determinant A into I3, where I3 is the identity matrix of order 3. Plus 1, you studied how to find out the cofactors of each element. If you form a matrix by taking the cofactor of each element and take the transpose of that, that is adjoint of A. Now, cofactor of this 2 is minus 1. Cofactor of this 1 is 1. So, cofactors of the elements of the first row is written as the first column. Similarly, cofactors of the elements of the second row is written as the second column. The matrix which we are getting is called adjoint of A. Determinant of this matrix is -1. That also you studied in +1. Now let us prove this relation. For this square matrix, A into adjoint A will be same as adjoint A into A, and that will be equal to determinant A into I3, where I3 is the identity matrix of order 3. This relation is applicable for any matrix, square matrix of order n. A, this is the first square matrix, and the adjoint of this matrix is this. Then you multiply. +1, you studied how to multiply two matrices. Multiply each element of the first row with the elements of the first column and add. So you will get first element as -1 because you are multiplying each element by its cofactor. Here we are multiplying each element of the row with the cofactor of some other row. So you will get a 0. Then this -1 can be taken outside. You will get a matrix like this: 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is an identity matrix of order 3. So we could prove this relation. A into adjoint A will be same as determinant A into I3. Now I have shown you A into adjoint A is determinant A into I3. Similarly, we can show adjoint A into A is also determinant A into I3. Now, for this matrix, you try to find out both A into adjoint A also, A into adjoint A also, and adjoint A into A, and you can show that it is equal to determinant A into I3.